In this class, we're going to go over past exam questions on uniformly accelerated motion. Okay, let's start with the first question. A car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. Okay, let's start by writing out the information that we're given in the question. We are given that a car takes off from rest. So we have question 1, solution. A car takes off from rest and covers a distance of 80 meters. So we've learned in our previous class that if a car takes off from rest, that means that the initial velocity of the car is 0. So in this case, u equals to 0. You understand? Okay? And cover the distance of 80 meters. So s equals to 80 meters. You understand? On a straight road in 10 seconds. So t equals to 10 seconds. Okay? So we are asked to calculate the magnitude of its acceleration. So here we are looking for acceleration. Now, with respect to this given parameter, which of the equation of uniformly acceleration motion are we going to use? Don't forget, we have 3 equations of uniformly accelerated motion. Which of those equations are we going to use to solve this question? We are going to use the second equation of uniformly accelerated motion, which is s equals to ut plus 1 over 2 at squared. You understand? Now, because the value of u is 0, that means that s equals to 1 over 2 at squared. You understand? I told you in our previous class that when a car or a body starts from rest, the initial velocity of that body is what? 0. You understand? And because the initial velocity is 0, hence the value of ut will be 0, because when you take the product of time and 0, that will be what? 0. You understand? Hence the equation becomes s is equals to 1 over 2 at squared. Okay, so with this we can easily determine the magnitude of the acceleration. Okay, all we have to do is that we have to substitute all these parameters into this formula. We know that s is 80, so this is 80 meters equals to, okay, there is no need. By the time we are done, we're going to put the necessary units. You understand? Okay, s is equals to 80. 1 over 2 multiplied by a multiplied by t squared. T is 10, so I'm going to have 10 squared. Okay, so 2 multiplied by 80, that is 160. So I'm going to have 160 is equals to a multiplied by 100, because 10 squared is what? 100. Okay, divide both sides by 100. This over 100. A equals to 1.6 meter per second squared. You understand? So the value of a, the magnitude of the acceleration is 1.6 meter per second squared. You understand? Okay, so let's proceed to the second question. Question 2. A bus traveling at 15 meters per second accelerates uniformly at 4 meters per second squared. What is the distance covered in 10 seconds? Okay, so let's start by writing out the information that we are given in the question. Okay, we are told that a bus traveling at 15 meters per second. Here, the initial velocity of that bus is what? 15. You understand? Because the ball is moving. You understand? We are not told that the ball starts from rest. The ball is already traveling at a particular velocity, which is what? 15 meters per second. So here u equals to 15 meters per second. U equals to 15 meters per second. Okay. A bus traveling at 15 meters per second accelerates uniformly at 4 meters per second squared. So the acceleration equals to 4 meters per second squared. Okay. Now, what is the distance covered in 10 seconds? So the distance is what we are looking for, and the time equals to what? 10 seconds. Okay. So with respect to the given parameter, how do we calculate the distance? Which of the equation of motion are we going to use? We're going to use the second. And in using the second, we can easily determine the distance covered in 10 seconds. You understand? The second equation of motion is this. This is the second equation of motion. So here I'm going to have s equals to ut plus 1 over 2 at squared. You understand? S will be equals to u is 15. So I'm going to have 15 multiplied by t. T is 10 plus 1 over 2 multiplied by a, which is 4, multiplied by t squared, which is 10 squared. You understand? Okay, let's proceed. S is equals to 15 multiplied by 10, that is 150. So I'm going to have 150 plus these two here, these two, I'm going to have 2 plus 2 multiplied by 100. Okay, so S equals to 150 plus 200. So S equals to 350 meter. 350 meter. You understand? So the distance that the bus covered in 10 seconds is 350 meter. Now, if you compare this question with this question, in this question we are told that the bus, what's it now? The car takes off from rest. You understand? So that means that the initial velocity of that car is what? 0. You understand? So hence the value of this, the value of ut in this case, the value of ut becomes 0. You understand? Because when you take the product of 0 and t, you are going to have 0. So the equation of motion becomes like this. Now in this one, we are told that the board is already in motion. Hence the initial velocity is 15. So this one have a significant value. You understand? So that's why I have 15 multiplied by 10. Do you understand now? Okay. So anytime you come across a question that says the body starts from rest and you're using the second equation of motion, just know that this is what? 0. So the equation becomes like this. Okay. So in an attempt to skip and make you to reduce, help you manage your time, you understand? Because this kind of question mostly come out in the objective, you understand? Okay. So let's proceed to the next question. Question 3. A body starts from rest and accelerates uniformly at 5 meters per second squared. Calculate the time taken by the body to cover a distance of 1 kilometer. Okay, we are given in the question that the body starts from rest. So therefore, the initial velocity of that body is 0. That is question 3. The initial velocity is 0 because the body starts from rest. Okay, it accelerates uniformly at 5 meters per second squared. So acceleration is 5 meters per second squared. Okay, so we are asked to calculate the time taken by the body to cover a distance of 1 kilometer. So time is what we are asked to determine, and the distance is what? 1 kilometer. Okay, so but there is one important thing that I want you to take note. You can see that in this question the distance is in kilometer, hence we have to change it to meter. You understand? So don't forget that 1000 meter equals to what? 1 kilometer. So the distance is 1000 meter. You understand? Okay, so having changed the unit to the necessary unit, you understand, all you have to do now is to know with respect to the parameters that were given in the question, which of the equation of motion suited the parameter. The second equation of motion does that. You understand? So here we can do we're going to have S is equals to ut plus 1 over 2 at squared. You understand? But because the initial velocity is 0, you understand, so S is equals to 1 over 2 at squared. Okay, so with this formula we can easily determine the value of the time. Okay, so S is what? 1000 meters. So I'm going to have 1000 meter equals to, there's no need for this, equals to at squared 5 multiplied by t squared all over 2. Okay, so here I'm going to have 2000 is equals to 5t squared divided by 5. I'm very sure you understand how I got, you understood how I got 2000. I take the product of 1000 and 2. You understand? Okay, so I got 2000, then divide both sides by what? 5. I'm going to have 400 equals to t squared. So t equals to square root of 400. So here t equals to 20. So the time it will take the body to cover a distance of 1 kilometer is 20 seconds. You understand? Okay, so let's have the last work example, last question for this class. A particle starts from rest and moves with a constant acceleration of 0.5 meter per second squared. Okay, 0.5 meter per second squared. The distance covered by the particle in 10 seconds is dash. A 2.5 meter, B 5.0 meter, C 25.0 meter, D 50.0 meter. Okay, that is question 4. Yeah, question 4. Okay, we are given that the particles start from rest. So here u will be equals to 0. You understand? The particles start from rest. U will be equals to 0, and acceleration is what? 0.5 meter per second squared. Okay, the distance covered by the particle in 10 seconds, s is what we are looking for, and the time is what? 10 seconds. So you can easily use the second equation of motion, you understand, to determine the value of s. So s is equals to at squared all over 2. You understand? S equals to 0.5 multiplied by t squared, which is 10 squared all over 2. So s equals to 0.5 multiplied by 100 divided by 2. S equals to 10. S equals to 10. Oh, no. That is 50 over 2. You understand? Sorry. S equals to 50 over 2. So S equals to 25 meter. You understand? The correct option in that question is option C. You understand? That is JAMB 1990. That is the question that we just solved. Okay, so you can see that it is easy to solve when you understand the basic concept. You understand? So that is a typical example that you might come across in your exams. Okay, so and this one provide question of exposure. You understand? Being exposed to the likely question that you might encounter in an exam, that is the best way to prepare. Okay, and that is why I take time to solve this kind of question. So to learn more, you can check the playlist of this video, Uniformly Accelerated Motion, on this channel. Okay, just check the playlist. You're going to see numerous past exam questions I've already solved. Okay, so that will be all for this class. See you in the next class.